No effective tune-up is possible unless the mechanical parts of the engine are functioning properly. The inlet and exhaust valves must be moving freely and forming a gas-tight seal with their seats in the cylinder head. The piston rings must also form a gas-tight seal against the cylinder wall. To check these parts, we need to perform a compression test. To conduct a compression test, we require the following items. Firstly, maker's specifications. Compression gauge, a clean 1-inch paintbrush, a spark plug spanner, an oil can, a spark plug gauge, and a label for each high-tension lead. We also require a fully charged battery, a healthy starter motor, and the engine should be at operating temperature before we start. Make sure a car with manual gears has the shift lever in the neutral position. A car with an automatic gearbox must have the shift lever in park and the handbrake on. Next, we remove the air filter assembly so that we can check whether the choke butterfly is in the off position. That is, vertical. We also open up the throttle butterfly fully. That is also in the vertical position. You can do this by simply having someone keeping the accelerator pedal down or jamming the linkage with a wedge. The reason for this is so that we get a full quantity of air going into the cylinder while we test the compressions. It's also important to check all the manifold bolts so that there is no vacuum leaks. Label each spark plug lead to the plug it is attached to. Disconnect at the coil the low tension lead, which connects to the distributor. Remove the plug leads, taking care not to cause a break in the carbon or hypalon core. Grab the lead close to the plug. Then we can clean around the plug with our brush so that no dirt can enter the plug hole and score the rings and cylinder walls. Now we can remove the spark plugs, taking care to keep the plug socket straight, and use a suitable socket with a rubber protection sleeve inside. Insert the compression gauge into the plug hole, and we are ready for the compression test. With both butterflies fully open, crank over the engine 3 or 4 revolutions, and take note of each cylinder reading in turn. Compression should be equal in all cylinders. Approximately 10 to 15% variation is usually allowed. 120 to 150 pounds per square inch or 1,000 kilopascals is normal. If 2 adjacent cylinders are low, we can expect a faulty head gasket. Listen for a chuffing noise at the carburetor throat to prove it. If 1 or more cylinders are down, it could be caused by leaking valves or faulty rings. To prove this, we could do an oil test as follows. With an oil can, we squirt 2 or 3 shots of oil through the plug hole. Crank the engine over a few times and test the compression again. If compressions increase considerably, then the rings are to be replaced. If some or all of the compression stay too low, then valves are leaking, which could be caused by tight tappets or faulty valves, both of which are not covered in this program. Remove the device holding the accelerator down. If the compressions are satisfactory, then we can proceed with the tune-up. First, inspect some of the parts of the ignition system for possible replacement, starting with the battery, which must be in good condition and fully charged, with the battery posts, cables and terminals not obstructing the flow of current. Refer to the follow-up section for checking and servicing the battery. Replace the battery and cables if necessary to ensure a full supply of electric current. Remove the clips securing the distributor cap. Observe its position and remove it. Clean the cap and inspect for cracks. Check the condition of the internal posts for excessive corrosion. Small amounts of corrosion may be left on and the cap used again. Check the center carbon post for wear. Most are spring-loaded. With an ohm meter, check the resistance of each lead while it is still fitted to the distributor cap. This will also show if there's a poor tower to lead connection. Reading should be consistent according to the length of lead and can be between 2,000 and 15,000 ohms per 300 millimeters, but check with the maker's specifications. Note which lead, if any, has a high resistance. Visually check all the leads to tower connections by removing one at a time, grasping the boot and twisting 1/2 turn to break the seal before pulling off, and inspecting for a blue-green corrosion powder. Firmly replace by fully seating the terminal inside the tower. Remember that the resistance type high-tension lead is easily damaged. Repeat the check again with the ohm meter, and if some leads still have a high resistance, then replace individual leads or the complete set. If replacing the set, remove one at a time and replace with a new one the same or similar length, changing the labels over as you go. Pull the rotor button off and observe the locating key inside and the corresponding part on the shaft. Check for a pitted or loose arm and cracks in the bakelite. Always replace the distributor cap and rotor as a pair. Check the condition of the low tension leads. Inspect the coil tower inside for corrosion or burning due to the high tension lead not seating in properly and causing a flash. If this has happened, then look at the outside of the tower. If the current is having trouble traveling inside to the high tension lead, it may find an easier path to follow through the tower or down the outside to earth, assisted by moisture and dirt. So look for cracks and carbon tracks. Having estimated your needs for replacement, you could need some or all of the following. Definitely replace spark plugs, distributor points, condenser, air cleaner element, and inline fuel filter if fitted. Estimate ignition coil, distributor cap, rotor button, high tension leads, battery cables, and battery. To carry out the work on the ignition system, we require the following items: screwdrivers, ignition spanners, a few pieces of clean cloth, some grease, an oil can, a pressure pack of lubricant, a little petrol, a fine stone or similar item, a pair of pliers, feeler gauges, some smooth, clean paper, a dwell tachometer, some white chalk, timing light, low pressure and vacuum gauge, a spark plug gauge, and a spanner for the distributor clamp bolt. Remove the dust cover over the distributor points, if fitted, and block all holes in the distributor plate with clean pieces of cloth to prevent small putts from falling inside. Note the position of the primary lead in and condenser terminal before removing the old point. Remove the contact points from the distributor plate. Wipe the plate clean. Remove old grease from the cams and evenly apply some fresh grease. Apply 2 drops of oil in the center of the shaft. This is what you are lubricating. Lubricate the mechanical advance mechanism with a suitable pressure pack which is fitted with the ignition tube. Remove a piece of cloth to block a hole in the plate and insert the tube to spray and lubricate. Replace the piece of cloth blocking the hole. Wipe the new contact surfaces with a petrol dampened clean cloth to remove the protective coating. Inspect the rubbing block and remove any high spots with a fine stone or wet and dry paper. This minimizes the possibility of the gap closing after a short time of engine running and causing the points to arc and burn, and also retard the ignition timing. Fit the new set of points to the plate and tighten the securing screws, only enough so that the base can be moved to adjust the point gap. If the points don't meet squarely when closed, bend the stationary point bracket to provide correct alignment. Do not bend the movable arm. If one or both of the point surfaces are convex, then contact should be in the center. Fit the new condenser. Turn the engine over by hand until the contacts are fully open. Set the point gap with a feeler gauge to the manufacturer's specifications and firmly tighten the securing screws. Turn the engine over again until the points are closed. Pass a clean piece of paper between the point surfaces to ensure that they are clean. Remove the cloth blocking the holes and replace the dust cover. Look for the locating key on the shaft and inside the rotor button and replace the rotor on the shaft securely. Look for any locating grooves on the perimeter of the distributor cap and fit it as it came off. Before fitting the new spark plugs, check the gap and adjust to manufacturer's specifications if needed. Clean the threads and seats in the cylinder head. The new spark plug should screw in easily by hand until seated. Tighten with a tension wrench to the maker's recommended tension. Over-tightening in an alloy head will damage the threads. Insufficient tension will not transfer heat effectively from the spark plug to the cylinder head. If you don't have a tension wrench, choke your hold on the socket bar like this. Now fit the high tension leads according to their labels and the low tension lead to the coil. Start the engine and run to operating temperature. A meter similar to this has several uses, including a dwell reading which will check the point gap. Connect the meter up to the engine as per instructions for a dwell and tachometer reading. Start the engine and let it idle. If the dwell angle is higher than the range indicated by the manufacturer's specifications, open the points up further. With the angle set, speed the engine revs up to 1500 revs per minute. If the dwell varies more than 3 degrees, then we have a fault in the distributor. Refer to the manual for diagnosis. With the dwell angle correct, turn the engine off and connect the timing light. Clean around the timing mark on the crankshaft pulley and mark it with chalk or paint to make it more legible. Clean the corresponding scale lines and mark clearly with chalk or paint the appropriate line for ignition timing as determined by the manufacturer. To time the ignition, loosen the distributor clamp just enough to allow the distributor to be turned without undue force. If recommended by the manufacturer, remove and plug the vacuum line to the distributor. Start the engine and run at a fast idle. Point the timing light at the timing marks and slow the engine revs down until the timing mark will not move any further back. Turn the distributor until the timing mark coincides with the appropriate defined mark on the scale. Do not try and road time the engine. To see if the mechanical advance is working properly, switch the meter to high tacho. Direct the timing light at the mark and run the engine slowly from idle to around 3,000 revs per minute, and the timing mark should move smoothly against the direction of the engine rotation. To see if the vacuum advance is working, set the engine revs to 1,200 revs per minute. Direct the timing light to the mark. Unblock the vacuum line and connect to the distributor diaphragm. The timing mark should again immediately move against the direction of engine rotation. If all is okay, stop the engine and tighten the distributor clamp bolt and remove the timing light. When checking the fuel system during a tune-up, there are two main items to consider: the carburetor and the fuel pump. From the air cleaner on the carburetor, check the element by holding a light inside and looking for holes and excess buildup of dirt. Replace the element if it's been on the car for at least 12 months during normal service. Look for petrol stains or evidence of leaks outside the carburetor. If leaking between the top casting and the body, the needle and seat valve may not be holding the fuel to the correct level. Check the float level if a glass panel is fitted to the side of the chamber. Look down the throat of the carburetor and open the accelerator quickly. A spray of fuel will be evident if the accelerator pump is working. If there is a fault in these three areas, we suggest you fit an overhaul kit or have it reconditioned by a carburetor specialist. If a heat riser valve is fitted in the manifold, check to see if it is free and working. Do not oil it. If an inline fuel filter is fitted, inspect for dirt and water, or if it is more than 12 months old, replace it. Inspect the fuel pump externally for leaks around the pipe unions and the glass or metal inspection cover. For a fuel pump pressure test, we need a low pressure gauge with hose and a tapered cone. Disconnect the pipe to the carburetor using 2 spanners. And connect in the tester. The gauge must be positioned within 150 millimeters above or below the carburetor. Start the engine and idle to approximately 500 to 600 revs per minute. The gauge should ideally read 3 pounds per square inch, or 21 kilopascals. If above that, we suggest fitting a fuel regulator. Any lower than 1.5 pounds per square inch, then a fuel pump problem exists. Refit the fuel pipe to the carburetor. And check the throttle linkage travel by having a person fully hold down the accelerator pedal. The throttle butterfly should be fully open. To adjust the idle mixture and engine revs on a single barrel or 2-stage carburetor, take note where the adjusting screws are located and their accessibility. If the idle mixture screw is fitted with an emission control limiter cap, do not remove these caps or try to adjust the mixture. Also note how to check if the choke butterfly is fully open. Check the air cleaner body and check the rubber seals. Fit to the engine and install a new element. Start and run until operating temperature is reached, checking if the choke is fully open. And adjust the idle revs to approximately 500 to 600 revs per minute, or otherwise as advised by the manufacturer. Turn the idle mixture screw in, that is, clockwise, until the engine begins to miss. This is a lean mixture. Then back the mixture screw out, counting the number of turns, until the engine begins to roll. This is a rich mixture. Then turn the screw in halfway between the missing and roll positions to obtain the steadiest, highest reading. If the idle speed has changed, then reset the idle revs per minute with the idle speed screw. And repeat the process of adjusting the mixture. The mixture screw should be the last one to adjust for the correct idling speed. The adjustment for a 2-barrel is basically the same. However, 2 mixture screws are fitted. With the engine at operating temperature, stop the engine. Then turn each screw in until they are lightly seated. Back each one out 1 1/4 of a turn. Start the engine. And adjust each screw in or out to produce the highest revs per minute reading. Screws should be adjusted to within 1/2 of a turn of each other. As a final check of all engine settings, connect a vacuum gauge to the inlet manifold. Start the engine and bring to normal operating temperature and run at idle revs per minute. The vacuum gauge should read a steady 18 inches. If the reading varies from this, then refer to the pamphlet of example readings for diagnosing. When the engine is cold, check if the choke butterfly has returned to its closed position. In checking other engine parts, examine the battery for signs of corrosion, cracking and leakage. Inspect hold-down brackets, terminals, cables and electrolyte level. Small leaks and gassing, the formation of hydrogen and oxygen, attacks the terminals. This causes corrosion, and unless removed, the terminals will be eaten away. High resistance is imparted in the terminal-to-post connection whilst in this state. Remove the battery cable terminals from the battery posts and clean. Clean the mating surfaces to ensure that there is no resistance to current flow. And coat with a non-metallic grease, such as petroleum jelly. Fit the terminals and tighten securely. Cover the terminals with the jelly. With a dirty battery, the top will attract electrolyte and become conductive. This deposit will allow a small but steady flow of current from one post to the other. This will cause a slow discharge of the battery. The battery hold-down bracket should be tight enough to hold the battery securely, but not over tight to place excessive pressure and cause case failure. Coat the battery carrier and hold-down bolts with the same spray. Check the electrolyte level in each cell. Most batteries have a correct level indicator, a lip, a slot, or exterior mark on the translucent battery case. Add pure water to bring electrolyte up to the level. If no mark is available, bring level to 6 millimeters above the separators. To prevent leaks caused by expansion pressure resulting in corrosion, avoid overfilling. If a battery uses large amounts of water, check for overcharging by the alternator and regulator. This will drastically reduce the battery life. An inexpensive device such as this charge indicator can quickly determine if the battery and charging system are in good working condition. Attach the leads to the battery. Red to positive, black to negative. To check the battery, switch on the car headlights and note the battery condition as shown on the meter. Recharge the battery if it is half or less. To check the engine charging system, start the engine. Run at a fast idle. The indicator should show full charge. If the reading is less than full, or the lamps are flashing, this indicates a fault in the engine charging system. The cooling system is to a lot of people very mysterious, but is basically very simple. Consisting of a radiator, cooling area in the engine block, water pump, rubber hoses, thermostat and its housing, fan belt and fan blades, in some cases a radiator expansion tank, radiator cap or caps in the case of expansion tank, and temperature gauge, the most important gauge in a motor car. We have a problem if there is excess rust in the radiator, or when you look inside a radiator and see lumps of dirt stuck inside the cooling tubes. We also have a problem if there are rust spots on the outside surface of the radiator, or a white build-up on the fins, which is fatal for the radiator. That's a sign of what we call in the trade electrolysis, which means a chemical attack on the radiator metal from within that weakens the material. Plus, the radiator can't eventually take the water pressure and will start to leak. In any of these events, the radiator sure needs attention. Next comes the engine block and its cooling area, which doesn't require a great deal of inspection, except for the Welsh plugs. They are a common cause of trouble. Once again, electrolysis attacks the Welsh plugs from within, and when they corrode through, they will leak and cause water loss. Not to mention overheating, so any signs of rust on the Welsh plugs, they need replacing. It would be a good idea to replace the plugs that are hard to get at with a brass type, and the others with a steel type. However, it is not advisable to have all the Welsh plugs in brass, otherwise electrolysis starts eating into the engine block. The water pump is fairly easy to inspect. Grab the fan blades firmly and move them about. If there is movement, the bearing is worn. If by any chance water leaks from a small hole on the lower part of the water pump, the seal is leaking. In both instances, the pump needs to be replaced. You could use a small mirror to check for water leaks to make it a lot easier and accurate. Hoses need to be checked regularly. If they're swollen, they need replacing. Check for external and internal cracks. It is a good move to replace hoses every couple of years for preventative care. Examine the fan belt for cracks and fraying. Check the belt tension. This should be quite firm, but don't over-tighten. The thermostat is not easy to check. The best indication for thermostat troubles is your keen eye on the temperature gauge. If the temperature goes over its usual reading, it could be stuck closed. And if it reads lower than normal, it could be stuck in the open position. Replace it, for it's not an expensive item, around $5 or $6. Also, I suggest to replace the thermostat every 2 years to reduce breakdowns. A thermostat has a definite job to do, so never leave it out for any length of time. Its function is to raise the water in the system to running temperature as quickly as possible. This is necessary to reduce engine wear when the engine is cold. Most wear in an engine takes place when it's cold. Check the expansion tank for leaks and rust, hoses for condition, and clamps for tightness. Check the rubber seals in the radiator cap and tank cap if it has one for splits and wear. Replace the cap if it has that old look, as it's likely that the cap doesn't seal properly. If the radiator has been drained of all water, refill it with 2/3 water and 1/3 of a coolant, which is available from your local parts store. It protects your system from rust and helps cool your engine. Before we test drive the car, we should check the exhaust system for leaks and ensure that it is properly fastened to the body. Replace any faulty part. Also remedy any oil leaks before we go any further. Most likely leaks to occur would be from the oil pressure switch, rocker cover gasket or gaskets. Replace any doubtful part. Now we're ready for the road test. The car should perform really well now. There should be no pinging or lack of performance. If the engine pings under load conditions, the timing is too far advanced. Check the manual for correction procedure.